Myself Anusha HS, Assistant Professor, Department of Chemistry, ATME, College of Engineering, Mysore. Today I am going to conduct the potentiometric experiment of FAS using standard K2CR207 solution. Potentiometer. The principle is involved in the potentiometer is when the pair of electrode is placed in the sample solution. In pair of electrode, here we are using the two electrodes. One is indicator electrode, another one is reference electrode. It shows the potential difference by the addition of the titrant. While we are adding the titrant to the solution, it's gradually changing the potential. It's mainly depending upon the change in the concentration of the ions. The potential developed depending upon the concentration of the ion given by Nernst equation. The Nernst equation is given by E is equal to E naught plus RT by NF ln Fe3 plus divided by Fe2 plus. So here the oxidation reaction takes place. So the Fe2 plus ion is undergo for oxidation and converts into Fe3 plus ions. So these are the chemicals and glass operators required to conduct the experiment. So pipette, 25 cm pipette, and distilled water, standard K2CR207 solution, 3 different concentration of FAS solution, and dilute H2SO4. This is the magnetic stirrer. We are going to take the beaker. Inside the beaker it's a magnetic pit. So these are two electrodes. One is indicator electrode, another one is reference electrode, burette and potentiometer. So these are overall setup for the potentiometer experiment, the chemicals required and glass apparatus. First we have to wash out the glass electrodes by distilled water. After that you have to take the FAS solution, ferrous ammonium solution. Here there are 3 different concentrations of the FAS solution. First I will take the FAS 1 bottle. First we have to pipette out twice because we have to pipette out 50 centimeter cube. This is the 25 centimeter cube pipette, so we have to pipette out twice. So now I pipette out FAS solution, 25 centimeter cube of FAS solution, and add to the beaker. Here there is a magnetic bit. The magnetic bit is used for continuous stirring of the solution. Again you have to pipette out 25 centimeter cube of FAS solution, and again you have to add to the beaker. You have to take the dilute H2SO4 10 centimeter cube it by using a measuring cylinder. So 10 ml or 10 centimeter cube of the dilute H2SO4 and add to the solution and immerse the electrode to contact to the solution and take the burette. Already I washed the burette and rinsed with the distilled water and fill the burette with standard K2CR207 solution. So here the complete setup is ready to conduct the potentiometric experiment. Just you have to set up the burette and switch on the potentiometer. So initially, first the solution potential, we have to measure the solution potential, or we have to take note down the concentration of the potential of the initial reading and add 0.5 ml of K2CR207 solution to the beaker. The potential should vary. So here we are observing the changing in the potential. So initially it is in 120, 137. So by adding the K2CR207 into the beaker, so the potential is increases. The potential is increase or decrease. It is depending upon the concentration of the solution. So it's it's a continuous and gradually increasing of the potential of the solution. Again, you have to add 0.5 centimeter cube of K2Cr2O7 into the solution. Again, the potential should varies. So the potential is gradually increases while adding the K2Cr2O7. And note down the values. At a certain point, you are getting a jump. Means the potential is 200 to 300. It's sudden jump you have to obtain up to 400, 450. Here we are observing the changing in the potential. The potential should be take the jump. So it's approximately 450, 455, 40. After that jump, you have to take 3 to 4 centimeter cube of K2Cr2O7 and note down the potential. So here we are observing the changing in the color of the solution. So initially it is in colorless, but now it's in a blue color. So it's while adding the K2Cr2O7 to the beaker. So the potential should be noted down here. So it's a volume of K2Cr2O7. You have to add 0.5, 0.5, 0.5. So it's a delta changing in the volume is 0.5, 0.5, 0.5. So the potential is, you have to take the potential here, and delta E is nothing but changing in the potential. So you have to calculate the changing in potential. After that, delta E by delta V. So delta changing in the potential divided by changing in the volume. You have to calculate and note it down, delta E by delta V. So after you have to obtain the delta E and delta V value, you plot a graph. So in the graph, in the x-axis, you are going to take volume of K2Cr2O7 in the x-axis. In the y-axis, delta E by delta V. So the potential should be gradually increases. So at one particular point, it should take the sudden jump. That point is called as an equivalence point. So that it should be the volume of K2Cr2 is consumed. That is referred to V2. Okay. So that experimental calculation, the normality of the K2Cr2O7 solution is taken as N2. It's already given because it's a standard solution. We have know the normality. After that, the volume of K2Cr2O7, it is obtained from the graph. The volume of FA solution is taken is 50 centimeter cube, and now substitute N2 V2 divided by N1. Then you will get in the normality of the FA solution. That normality you have to substitute here and multiply it with the equivalent weight of the FAs. So we already know that equivalent weight of the FAs is 392, and calculate and multiply with 50 and divide by 1000. So then you have to obtain the weight of FA solution in 50 centimeter cube of given solution. Thank you for watching this video.